Okay, so very good morning to all of you. So today we are going to perform our first experiment through the tanner we will do, okay, the VLSI. So firstly we are going to open this S-edit, that is the part of tanner EDA. Here we have opened the window. This is the UI of S-edit, okay. S means semantic, okay. So click on this file menu, click on the new button and we'll click on the new design. Then here we will name the design. Since we are going to perform NMOS, so we can name it NMOS. Okay, NMOS. Suppose NMOS VI. You can write NMOS VI characteristic here. Okay. So here you can create this design in any folder. Okay, make any folder. So here by default it has chosen my document folder. Okay, so I can also choose any other document, sorry, any other folder if I want. Okay, so you can just click on this browse button and here you can choose in which folder you want to save this design. Okay, so leave it, I will save my this design here only. Okay, I'm clicking on this OK button. Now after clicking on this thing I will add the library file, so I will click on this add button. Then here by default, since I have already done many experiment on tenor, that's why it has given me the details where my tanner all file is present. All file means this tanner library file is present. So I will show you that where actually it is present. I will click on this browse button here. Remember, I think, yeah, this is the document folder. This is my PC document folder. Okay, so here the Tanner Tools version 16.0 is present. Here I will click on this library folder. In library folder, this all folder contains my all.tanner file. Okay, so this is the full data of the library of the Tanner. So I will click on this thing and I will click on open button and I will click on OK. So after clicking on this thing, just see here on the left hand side, we are having all the libraries. Okay, so just click on this IO pad, you will find different devices here. Click on the logic gates, you will find different devices here. In the spice element also. So by clicking on the different devices folder, you will get the different types of devices which are contained in this library. Okay, so now when I'm going to click on the devices, I will find the NMOS, PMOS, and other things which we need for the ongoing experiment and for the upcoming experiment in this lab. Okay, so for picking up this thing, we firstly need a breadboard. Okay, so where we can uh, put these devices. Okay, so for doing this thing, we will click on the cell button, click on new view. Okay, so this is cell 0. My device name is NMOS only. Okay, the view type is schematic, so it is okay. We'll click on this OK button. After clicking on this OK button, a small breadboard type window is present here. I will click on this maximize button. So here you can see many dots are there. Okay, in which we can keep these devices. So firstly we will zoom out here. Okay, you can use your mouse scroll button. Okay, for zoom in and zoom out. Okay, so this is here. So now we can add these devices. Okay, so we will take firstly this NMOS. Okay, after left clicking on this NMOS, click on this instance button. Okay, when you will click on the instance, we will choose one NMOS. Now just see, when I am dragging my mouse here, okay, one NMOS device we are taking. Okay, remember, do not try to left click many times. As many times you are going to left click, okay, that many times the NMOS devices would be kept on this breadboard. Okay, okay, here you can see the device name is there, the interface is there. Okay, if you want you can change the instance name here also if you want. Okay, so I'm just going to left click here. Suppose in the center I'm keeping it, I'm left clicking it. Okay, now just see, when I have left clicked it, one NMOS instance has been already placed on the breadboard. So I'm hovering my mouse here. When I'm going to left click again, this device is again going to be kept on the breadboard. So I didn't need that thing. Okay, so I'm going again back and click on this done button. I'm going to click on this done button. So I'm done with this NMOS device. So for taking the VI characteristic, we need to voltage source also. Okay, namely I think VGS and VDS. Yeah. So what we will do, we will check on this thing miscellaneous. We will found ground here. Click on the ground again. Instance. Again, I will click a ground here. Okay. Then I will click on done here. Now we'll just find where is the voltage source. I think the spice element. Yeah, yeah. In the spice element, we will find this voltage source here. Just click on this voltage source. Okay. So now when I have click on this voltage source, just look here. A small thumbnail of this voltage source is shown here. Okay. So voltage source can be of different time. You can by clicking on this left and right arrow. Okay. You can check many type of uh, sources here. Okay. So basically, we are going to take the VI characteristic. So we will take the normal DC voltage source here only. So this is normal DC voltage source. Click on this instance. So we need two DC voltage source, one for gate source and one for the drain source part. Okay. So I'm going to left click one source here and the other source here. So just see here, I have taken the two instance of this voltage source. Okay. Then I will click on this done button. Now you can see here this name of the first source is voltage source 1 and you can see here. Okay, I have just clicked on the left arrow of my keyboard. Okay. Then I will click this right one. Okay, so this is this. So here you can see this voltage source is a fixed one. That means it is having a 5 volt. It is a 5 volt source. So the for taking the VI characteristic, what we need now, we need to vary these voltages, this voltage and this voltage also. Okay. So firstly, what we will do, we will rename the source. Okay, we can just zoom out this thing. Okay, it is no, it looks very tiny. Okay, so what I'm going to do here, I'm just going. So here you can see in the right hand side also, this is the whenever you are going to click on anything now here, suppose NMOS or this voltage source or this ground, here in the right side you will find the characteristic of these devices. Okay, in the last also you will find that at which position on this breadboard our ground is placed. Uh, Similarly here so this is the main data. So here I will change the name of this source. We are going to rename it. Suppose voltage DS or volt DS. We'll keep the name here. Okay, done. And this one also I will rename it. I will keep it volt GS. Suppose yeah. Okay. So I have renamed this thing. So renaming means that we are just going to rename this thing. Now you can see here the characteristic of this device hasn't changed. It is now also going to provide a fixed 5 voltage DC source. Okay, so we need to actually vary this source. Okay, so how we are going to do that thing? We can't at this moment we can't vary the voltage source. Okay, so af- at the point when we are going to run the simulation now, you will find that we can use some parameters data to change this thing. Okay, so I will show you these things afterwards. Okay, so for firstly we need to rename this thing. Okay, so suppose volt gs, suppose I'm here, sorry, here this voltage, just look here, this V voltage is containing this 5 volt. So I'm going to rename this thing by a variable, suppose VGS. Since this is the voltage for gate source, so I have renamed it by VGS. Similarly, I will rename it here by VDS. Okay. Why I have done this thing, I am going to tell you. I have done this thing because it was before changing the name. Previously it was having a 5 volt data here. Okay, that means that it can give only a 5 volt DC voltage. But now I have renamed this thing to a variable. Now what I will do now, before running the simulation, I will vary this variable, okay, from suppose 0 to 5 volt or 0 to 4 volt. And when this data will vary, this whole voltage source data will vary. Okay, that's why I have renamed this thing. So now I need to connect the connections here. So for doing that thing, I need wires. Okay, so here, yeah, this thing, you can look at this thing is wire. Click on this thing. So for making a connection, these are the ports. Okay, these whole parts, just look, I'm just zooming in, these points are the ports. Okay, so just what you need to do, just make a left click and then drag the wire here from here to here. Okay, again click on the left click. Okay, one connection from here also, from here to here, from then here again to here. Yeah. Okay, so just by clicking on the left click buttons, okay, you can connect the wire. Suppose you want to delete something. Okay, suppose this wire you want to delete or some other wire you want to delete. While making the connection, you can use right click button also at that time. But if you have made the connections, then afterwards you need to delete it by you can delete it by your delete button on the keyboard. But firstly you need to select this line. So for using the select buttons, you need to click on this mouse. Click on this mouse button. So this is basically the select menu. We have clicked on this thing. Now we will select this wire and then we can delete it. Okay, similarly we can select this thing. While whenever we are going to select anything now, here by default it is showing yellow color. Okay, so you can change these things afterwards also. We don't need to change the color here. Okay, so I'm going to again join this wire here from here to here. Done. From then from again from here to here. Okay, and I will connect the length to this part. Okay, I've connected it here. Then just connect this VCS negative part. Okay, from here to here. Okay, I'm not able to connect it here. I will click on the left, right click, sorry. Then I will take one wire from here and then to this point here. Now this is working correctly. Again from the here to here I have connected this thing. Okay, so here you can see that we have made the connections here. Okay, now our circuit is complete for this experiment. Okay, this is a very simple circuit for providing this VI characteristic. Okay, so now we will check firstly whether we are where connection whether the connections which we have made is correct or not. So we will click on this red check mark button. Okay, click on this red check mark button. Here it will show that whether our circuit is having error or not. So yeah, so it is showing that yes, one cells has been checked, zero error and zero warnings were found. Okay, so remember every time that errors should remain zero. Okay, if there are warnings, we can correct it. Okay, or if we leave the warnings point now, then also our in the parameter portion when we are going to run the simulation, we will not get a use error. Okay, but we will get little bit error when we are having some warnings. Okay, but if there is any error, a single error is there, then we are going to have a huge difference between the ideal and this practical characteristic whenever you are going to run the simulation. Okay, so remember every time that errors should remain zero. We could avail the warnings point, but yeah, since this is the beginning, so we will try to have zero errors and zero warnings. Okay. Now this thing we have done. We will move on the parameters part. Okay. So click on the setup simulation part. So now we are going to set up the simulation. So for general portion, we are going to include the library files here. Okay. So remember one thing that at the beginning also we have added a library. Okay. So that library was having all the command files here. Okay. Now for running the simulation also we need some library files. Okay. So we will click on this library file. Okay, so here is the browse button for this library. Just click on this thing. I will show you whether where the library file is present. It is present, I think, in the library folder only. I think in the models, yes. In the model, this thing generic underscore 025 dot lib. So this is basically the library file which we need for the simulation. Without having this library file, without this library file, your simulations can't run. Okay, so just see here I have chosen this thing, and after this thing just make a space and uh, just write tt tanner tools here. Okay, since these library files can be used by other simulating software also, since we are going to use the tanner tools for this thing, so I have added a space and tt, that means for tanner tools. Okay, now after doing this thing, this is net listing option, we don't need these thing, hierarchy priority also we don't need, additional spice command we need parameter. Okay, okay, yeah, we will need some parameters. What the parameters are there are two parameters, see here, vgs and vds. These are the two parameters. Okay, so we will just add parameter, click on this thing. Okay, so the firstly is vgs. Okay, vgs, the value of this vgs. Okay, till what value we need to run this thing, so we'll provide these things here. We will give a value of 4 volt here in vgs, and there is one more parameter, this is vds. Okay, so I will add one more parameter named vds. This here also I am going to give 4 volt. Okay, you can give till 5, 6, 7, 8, it's up to you. Okay, so yeah, done this thing. Acha, one thing you need to check that whatever the name is present here. Okay, the name here also we have given the same. Okay, I mean to say that try to check that if this thing is in capital letter, here also use the capital letter only. Okay, sometimes what happens now, if suppose this vgs is in small letter, or suppose some letters are in capital and some letters are in small, and here you have used only capital letters, then in that cases you might get any error. Okay, so try to give the name similar. Okay, now in the spice option we didn't need anything, we need to, yeah, we need to give dc operating point analysis. Okay, when we will use the transient part. Okay, then we will use this transient analysis. Suppose you need to give and use any transient analysis here. Okay, so in that case we will give the time part, that till which period this simulation is going to happen. Okay, suppose I'm going to give here a maximum of 100 nanosecond. Okay, so this is the basic standard. Okay, not in capital, I think in small it is going to work. Yeah, so give the stop time 100 nanosecond. Now it is asking me the maximum step size. Okay, so step size we can give 5 nanosecond, 2 nanosecond, 10 nanosecond. Okay, but remember that whatever we are going to give here data. Okay, since I have used, just see here I am giving here 10 nanosecond. Okay, so that means that after processing 10 times this analysis, it will stop at 100 nanosecond. If I will give here suppose 9 nanosecond, then what happens now? after processing 11 times, it will come to 99 nanosecond, and for 1 nanosecond it will show us the error. Okay, so try to give here those values for which we can get an LCM of this 100 nanosecond. Okay, so now we need the VI characteristics, so we will prefer this DC sweep analysis. So we are here, it is asking me that for DC sweep analysis, which values we are going to change. So firstly, we have changed this VGS, right here VGS. So start value of VGS should be 0 volt. Okay, and after having this thing, it is again asking me that what should be the stop value. So here you don't need to mention volt also. If you want to mention, you can mention. You don't need to mention, because here already we have mentioned this VGS in this thing. So this already means that, yeah, this is a DC volt. So stop value, we have already given here in the parameter section. We have already given the 4 volt. Okay, so here also we will give 4 volt. So step size we will choose. Suppose you can choose 0.2 volt. Okay, so that means for every zero point 0.2 volt, it is going to check the values of data. And here in the sweep type, we'll choose the linear. Okay, similarly here also we will choose VDS. Start value is again 0 here. Stop value, and the stop value also will give 4 here. Step size we can give again 0.2 here. Sweep type will remain linear. Okay, yeah, okay, so we have done the spice simulation setup here. Okay, we will click on this OK button. Okay, so after doing all these things, we can carry out our simulation process. So you can click on this run button here. So when we have clicked on this run button, just see this device simulation is going to start. We'll wait for a few moments. Okay, so a T-Spice has opened here. It will check all the commands data. So here see, it is running now. So it has completed this part. In the T-Spice you can see here uh, the setup which we have done, it has completed. Okay, the setup has completed, but it is not showing us any graph of this thing. Okay, the graph is shown by this thing. Okay, so okay, what here we have done. Okay, okay, just close this T-Spice. Okay, yeah, so it hasn't shown us any type of graph, because we haven't tried any spice command here. Okay, we need to add a spice command. So spice command is what now? Spice command is basically, it contains all the simulation output data. Okay, so whatever you need to get the output now, you have to choose that thing from here. So here the voltage is present, we need to find the current here. So for output portion, suppose I need to find the current. So click on this, not no, this one, this print current. Click on this thing, click on instance, and put this thing on the wire. Okay, then click on this done button. So this is the print device terminals. Okay, so this will show us the current data which is going through this wire when the voltages of VGS and VDS are varying. Okay, so we need to check that whether this print device is currently in AC mode or DC mode. So we will check here the analysis. Yeah, the analysis is in transient mode. Transient mean we need to just choose here DC. Okay, and the device name is X1 here. Okay, so it is going to provide the print current of the X1 device, but here my device name is NMOS1. So I'm going to change the device name of this print command, uh, NMOS1. Okay, NMOS underscore 1. Now one thing is here, since you are going to measure this current here, So we are going to add one letter M here. Okay. So now the device name has changed to NMOS underscore one. Now it will show us the data. Yeah, I think everything is okay here. I will again check the simulation part here, that whether my circuit is okay or not. Yes, zero error and zero warnings are found. So everything has been set up. We will run this thing. So again, T-Spice will run firstly. Okay, then afterwards we are going to get the graph. So we'll wait for some moments. Okay, so here you can see here that the T-Spice has already been opened. Okay, so it will firstly check my whole data, simulate it, and then yeah, just look at the W edit. We have got our graph here. Okay, so here look at the bottommost part. Here is the data of VDS. So VDS is constantly running in the x-axis here, and here in the y-axis you can find this amps. That means the current part. Okay, so here in the y-axis you can see the current. Here in there you can see the VGS data is also running. Okay, so by varying this VDS and VGS, we have got the different graph data. Okay, now if you want to see that here, that what is the value of x and y, these things you can do. Okay, here by the clicking on a button you can add the text also. Okay, whatever your name is, suppose since my name is Rajan, I can name it here Rajan, and I can add it to the chart. Remember to add these names every time whenever you are going to plot any graph. Okay, and so this is how you are going to uh, run the simulation, and this is how you are going to get the graph. Okay, if you want to zoom in, zoom out, you can use these things. Okay, here also if you want to print this thing, you can print it, or if you want to save, click on these things. Okay, so you can save it through chartbook also. I am not going to save these things. Okay, so this is the graph, this is the output characteristic, okay, of this NMOS one VI. Okay, so I'm just going to close this thing. I'm not going to save this thing. Okay, so this is basically the circuit of your this NMOS VI characteristic. Okay, so remember every time that whenever you are going to run the simulation, kindly close the other softwares which if you are running in the background, kindly close those things. Okay, because VLSI tool actually need huge amount of RAM and the processors part. Okay, processing, sorry. Okay, so this is the whole part of this video. I hope you have understood that how to execute this uh, experiment, and later on we will explore some more experiment also if needed, and I will provide you data and I will provide you help also, that how you can use the standard tools for managing and for exploring various circuit simulations. Okay, so thank you for joining.